Hello, and thank you for joining me at AWS ASEAN Summit Online. In this session, we will go through on what you need to know and what things to do to optimize your costs on AWS. Story will be broken down into stages of your journey. Start from the stage you design a minimum viable product or MVP to the stage where you run a critical production scale workload. My name is Arian. I am a senior solution architect at AWS Indonesia. Let's get into it. So, in this session, you will learn about first, what are common cost challenges that faced by a new AWS users. Second, things to know about cost optimization when you start your journey on AWS. And third, how to optimize control costs and optimize costs in each stage of your journey. Whether you are running on a small startup or work in a big enterprise, and whether you just started your cloud journey or already run your workload on the cloud, we heard from our customer, what are your needs involved in costs? You want to operate within your budgets. You want to gain cost efficiency confidence. You want to eliminate waste. You want to know that you are spending your money in the right way and you are spending it on the right things. And then lastly, you want to identify optimization opportunities. But how do you know there is an opportunity for optimization? Well, knowing the goods looks like is a beginning step. Second, knowing what to do, how to do, and what tools are available to help you are the key in order to optimize your spend. There are some challenges that you might have to achieve those needs. One of those is that there is always changing priorities and lack of urgency on cost. Sometimes cost is really important depending on economic and business condition. Sometimes the importance of these cost efforts may not be as high on the list, and that will change as time goes on. Next is, you might don't have skill, knowledge, and tools. You might not know how to assess, set up, refactor, or modernize your environment. You may not have the technology and the ability to do something that's useful for you. And last is what we call finance engineering dichotomy. The finance and engineering sometimes have conflicts and it needs to be managed. They frequently have different priority and it needs to be adjusted. Let's look into what you need to know and things you can do to optimize costs on AWS. Sometimes with a lot of knowledge, resources, options, techniques, and tools that are already available, it makes you overwhelmed. So here I will divide the list of knowledge and know-how points based on the typical journey of AWS customers. Your journey often starts from the idea of building a new product or application, and then you decide to use cloud. The next stage is designing the product and the application architecture. After, or even while you are still designing, you might start creating an AWS account and start using it for turning your idea into a working MVP. You might also need test or staging environments. Finally, you will release your product and manage your production workload. In this section, we will focus on the very first stage. It is when you start thinking to use cloud for turning your idea into a product. While moving to the cloud improves agility and gives organization easier access to IT resources, there is some basic knowledge that your team or organization need to learn about costs. Cloud computing brings a mindset change from purchasing resources upfront to a new model of accounting for resource usage at pay-as-you-go prices. You might want to learn on how to do TCO analysis for cloud adoption, or just contact our AWS representative to help you. It is also important for you to know that AWS provides AWS Calculator tool to help you estimate your spend. Besides that, you also need to know the cost optimization principles. One of the cost optimization principles that I want to share is shared responsibility model from cost management perspective. Cost optimization is a shared responsibility between AWS and you. As you can see here at the bottom, AWS provides tools for cost management and optimization. AWS lower price over time. We provide guidance and facilitates information sharing. And we innovate and enhance customer ability to manage and optimize spend. On the top of the diagram, as you can see, customer responsible to undertakes cloud business planning and forecasting, allocates enough budget, and establish a finance engineering partnership. You also responsible to drive visibility, allocation, accountability, and ownership of spend. Lastly, you are responsible to assign and manage resources to make spend more efficient and predictable. Other principles that you need to know and learn are what we already documented in AWS well-architected framework. This helps you understand and decision you make while building workload on AWS. Basically, there are 5 focus areas for cost optimization in cloud. First, practice cloud financial management. Second, awareness of expenditure and usage at all levels in organization. Third, select cost-effective resource. And fourth, manage demand and supplying resources. And fifth, optimize over time. Let's zoom in further on each of them in accordance to your cloud journey. Stage 1 is when you design the application architecture of your MVP or your greenfield application. In this stage, you might yet creating an AWS account, but you are focusing on architectural pattern and the technology or services that will be used for your MVP. In this stage, you need to practice cloud financial management. You can create programs across your organization to create a cost-aware culture and cost-aware processes. Establishing a partnership between finance and engineering is also important. The engineering team who are responsible to architect and build the product should select cost-effective resources. You need to know resource pricing is different in each AWS region. While as a best practice is to seek to place computing resources closer to users to provide lower latency and strong data sovereignty. Using the appropriate services, resources, and configuration for your workload is key to cost savings. You want to design application architecture to meet your business requirements, but you have to consider the trade-off for cost optimization. Ensure that you have a balance between cost and other well-architected pillars. Consider the time saving that will allow your team to focus on retiring technical debt, innovation, and value-adding features. AWS provides various compute options. You can use application-level services such as AWS Elastic Beanstalk, Amazon ECS, Amazon EKS, or serverless services such as AWS Fargate and AWS Lambda that also give you other benefits because they scale in performance and cost in line with usage. AWS also offers the broadest set of databases and analytics services for customers to lift and shift their database workloads to the cloud. And customers are doing this at record levels across many different areas. First, relational database. For customers wanting to move away from self-managing Oracle, SQL Server, MySQL, PostgreSQL, and MariaDB databases, AWS offers Amazon RDS and Amazon Aurora. Second, non-relational databases. For customers wanting to move away from self-managed non-relational document store and key value stores such as MongoDB, Cassandra, Redis, and Memcached, AWS offers DynamoDB, DocumentDB, Elasticity, and managed Cassandra service. Third, hybrid cloud databases. Customers that are looking to deploy fully managed database instances but require workload residency be maintained in on-premise environment can utilize cloud hybrid services such as RDS on Outpost and RDS on VMware. All those services help you to reduce effort and operational and might reduce the cost as well. While you design your application architecture, you need to know the data transfer cost components and ensure that you optimize data transfer costs. Think of some architectural design considerations such as network optimization and application optimization to reduce the amount of data transfer. Another example is select services such as Amazon CloudFront to reduce data transfer costs. Now, let's talk about stage 2, the time when you first create an AWS account and then set up a sandbox environment to run your MVP. In this stage, you might also think to create other environments, such as test environments, which might be used and managed by a different team. Here is the list that summarizes the know-hows in stage 2. In this stage, you need to know how to create account structure. Set up cost control by creating enforcement policies and creating notification or alert. Prepare and start to perform basic monitoring of your cost and usage. On selecting cost-effective resources, you have to start doing right-sizing activities and also select the right purchase option. When you start to use cloud, you pay only for what you need. You can supply resources to match the workload demand at the time they are needed. This eliminates the need for costly and wasteful over-provisioning. If you do not familiar with right sizing or right purchase option, don't worry. We will run through more details on this on the next slide. First thing that I highly recommend after you create your AWS account is to use AWS organization to set up separate members account for each environment lifecycle, such as development, testing, and production. And then aggregate these linked accounts using consolidated billings. Consolidated billings allow you to consolidate payments for multiple members' AWS accounts while still providing visibility for each account resource consumption. To control costs, it is important to set up service control policies or SCP in your AWS organization. You have to minimize the creation of resources that are not required. In AWS organization, you can also set up tag policies which can be helpful to enforce users to apply tags to your AWS resources. Then perform analysis on tag resources using a cost monitoring tools. Next, using AWS Identity Access Management or IAM, you can control who can create and manage AWS resources, the type of resources that can be created, and where they can be created. Lastly, controlling cloud spendings means you don't want to spend over budget, right? Well, you can monitor your estimated AWS charges by using Amazon CloudWatch. And the alarm triggers when your account billing exceeds the threshold you specify. Alternatively, I would suggest you to create at least a monthly cost budget using AWS budget in order to stay alert on your spending. Preparing for cost and usage monitoring means we assign organization meaning to cost and usage. This can be done by implementing tagging strategy. You can add tags manually or use AWS Tag Editor to manage tags of multiple resources, or use AWS Lambda and other AWS services to automate tagging creation. After you apply tags to your AWS resources, you should activate cost allocation tags to make it easier for you to categorize and track your AWS costs. AWS also provides another level of management capability in addition to tagging. You can use AWS cost categories to assign organization meaning to your costs without requiring tags on resources. So, once you have prepared cost and usage monitoring, next, you can dive deep into your usage pattern and cost drivers using AWS Cost Explorer. It makes it easier for you to review your monthly trends, conduct free-form data exploration using the filtering and grouping functionality, and save your progress as a custom report. Now, let's talk about real action to lowering your costs by reducing waste. When you start running MVP or a new workload in the cloud, you usually don't really know what type of compute instance to use. Then, often it turns into you pay for what you provision instead of you pay for what you use, because the resource that you provision is overcapacity. For instance, you provision an EC2 instance with 16 vCPUs and 64 gigs of memory, but CPU utilization of that instance never reached 50%. So you waste about 8 vCPUs. That is the reason why you have to use the lowest cost resources that meet the requirements of the specific workload. We call this right sizing. You should perform a test of your workload and adjust the size of resources to optimize for cost. Monitoring resources while you test is also important for selecting resource size or type based on workload and resource characteristics. Another best practice is perform cost modeling. An AWS Compute Optimizer can help you by providing right sizing recommendation for compute resources based on historical usage. Today, Amazon EC2 gives you the option of choosing between more than 350 different instance types distributed across more than 30 instance families. You have the flexibility to choose the combination of instance type and size most appropriate for your application today. And you can always change the type you use later as your business and application needs change. Likewise, you can choose the lowest price storage volume that match with your performance requirement. And I would like to tell you about GP3, a new type of SSD EBS volumes that lets you provision performance independent of storage capacity and offers a 20% lower price than existing GP2 volumes type. The first step in right sizing is to monitor and analyze resource utilization to gain insight into instance performance and usage patterns. You can use Amazon CloudWatch to observe CPU utilization, network throughput, and disk I/O. You can also regularly monitor using Amazon EC2 usage reports to view in-depth usage data for all your EC2 instances. Here is the example. I'll just take you through in reducing cost by right sizing. The idea here is use more smaller instances rather than fewer larger instances. In the diagram, the blue lines show an example of the application usage pattern, and the orange boxes here represent instances deployed to handle the demand. We use M5 large instances here that cost about 10 cents an hour. As you can see here, we have 3 instances for the first 3 hours. Fairly low utilization. Then the demand goes up. We add another 1 instance. So in the hour 4, we have 1 instance in high utilization and 1 additional instance in very low utilization. So in total here we have 29 instance hours, but a lot of them are in low utilization, which means we have resources that we are paying but we are not using. Using those large instance type, we need to spend about $2,000 a month. Well, what if we replace those with different instance type and would achieve the same performance? Here, we change to T3 medium instances and we are going to have to use almost twice as many of them, 59 versus 29 number of instances. And you can see on the right side, T3 medium price is 4 cents an hour. The financial implication of this is about $1.8 thousand a month. So we have saved about $240. It's about 12% reducing in spend. Well, that shows you that we can optimize costs by using smaller instances and auto-scaling features. Right-sizing activities should also apply to other compute resources such as AWS Fargate and AWS Lambda. It is your responsibility to do performance tests of your Fargate instance or Lambda function. Pricing for both services are calculated based on the vCPU and memory resource use. For your Fargate instance, you need to do performance tests in order to know the optimal vCPU and memory configuration. Similar case when you use Lambda. Since Lambda allocates CPU power linearly in proportion to the amount of memory configured, you need to benchmark Lambda function execution with various memory settings, and then view memory usage in AWS CloudWatch logs. For Lambda, it is recommended to identify your function in memory bound or CPU bound. For both Fargate and Lambda, you also need to minimize your deployment package size and complexity. It will reduce time that it takes for your deployment package to be downloaded, and prefer to use simpler frameworks that load quickly. Amazon S3 offers a range of storage classes designed for different use cases at corresponding costs. This includes S3 standard for general purpose storage or frequently accessed data, S3 intelligent tiering for data with unknown or changing access pattern, S3 standard infrequent access, and S3 one-zone infrequent access for long-lived but less frequently accessed data, and Amazon S3 Glacier and Amazon S3 Glacier Deep Archive for long-term archive and digital preservation. Our advice is to choose the right S3 class based on your access requirements. AWS has multiple pricing models that allow you to pay for your resource in the most cost-effective way that suits your organization needs. First is on-demand instances. This is where you launch compute capacity where you pay by the second. There are no long-term commitments, great for spiky workload as you are defining your needs. Over time, as you really understand that you will need for the foreseeable future, it's great to look into saving against your on-demand instances with reserved instances. Reserved instances will give you significant discount for compute instances with 1 year or 3 year commitments. And we recommend this for workload with steady state usage. For computes, whether EC2, Fargate, or Lambda, I would like to recommend you to focus on saving plans to optimize costs against your on-demand infrastructure. Saving plans provide great discount for more flexibility across your on-demand workload. And finally, to truly optimize your cost against scaling performance, you want to think about tapping into our spare capacity through what we call spot instances. Spot instances are the same as on-demand instances, except the difference is that AWS can interrupt the instances whenever AWS needs the capacity back. In exchange for the potential of being interrupted, you can achieve up to 90% saving off of on-demand prices. So these type of instances are great for fault-tolerant flexibility and stateless workloads. So let's understand. In this slide, I want to focus this talk on saving plans and spot instances because these are going to really help you optimize against the saving and performance optimization within your workloads. So basically, we have on-demand instances and spot instances that are actually launching capacity for your workload to run on, right? Spot instances launch capacity and optimize costs directly inside them. On the other hand, saving plans and reserved instances are mechanisms for you to optimize against on-demand instances. Okay, now let's talk about how you can optimize costs by maybe changing your application architecture before you deploy it into production. While you are still in development or testing stage, it is important to think ahead how you supply resources to match the production workload demand at the time they are needed. You can also think of modifying the demand using a throttle, buffer, or queue to smooth the demand and serve it with less resources. Amazon API Gateway can help you implement throttling, while Amazon SQS, Amazon Kinesis, or Amazon MQ can help you to implement buffer or queue-based approach. Cost optimization through managed supply resources can also be achieved by leveraging the elasticity of the cloud. AWS provides several mechanisms to automatically increase or decrease your resource capacity to meet changing demand. For EC2 workload, you can use AWS auto-scaling. For container workload using Amazon ECS, there is ECS capacity provider. For Amazon EKS, you can implement cluster auto-scaling. Alternatively, you may also use AWS Fargate, AWS Lambda, which removes the need for you to manage resources. For demand that is predictable or well-defined by time, you can use scheduled auto-scaling. You can also leverage the AWS APIs, AWS SDKs, and AWS Cloud Formation to automatically provision and decommission entire environments as you need them. Well, that was quite a lot of action considered to be done for cost optimization in the stage 2. Now, how about stage 3? The stage when you run and manage critical production scale workload to serve real customers. In this stage, most of the know-hows and action are similar to the previous stages, but you should be more careful of what you do because it is production. You don't want to implement major changes and have a bad impact on your customers, right? As you can see on the slide, the points listed here are about how you can detail out, customize, dive deep, iterate, and tune of what you do in the previous stages. Let's talk about it in more detail. When you run production workload, you start knowing your real customer demand. After a few weeks or months, you know the traffic behavior. Then, you can perform modeling and forecasting your future spend. Based on that, you might want to set up an AWS budget with a different budget for every month in a year, and a more specific budget for the group of services that you use. Once you've done that, you can create AWS budget report so that you can proactively monitor and review budget performance. On the other hand, you can perform custom and deep analysis on your cost and usage. I suggest you enable Cost and Usage Report or CUR in the billing dashboard to have a granular cost and usage data collection. After that, you might want to create an enterprise cost intelligence dashboard using Amazon Athena and Amazon QuickSight. Additionally, you can use AWS Trusted Advisor and Reserve Instance and Saving Plan recommendation to identify potential savings. To ensure that you always have the most cost-efficient workload, you must regularly review the workload to know if there are opportunities to implement new services, features, and components. You have to always remember that cost optimization and cloud financial management is ongoing effort. You have to build your muscle memory of your organization to practice optimizing costs. I'd like to leave you with this takeaway slide that summarizes the know-hows in every stage of your cost optimization journey. In the very first stage, important to you to have basic knowledge about cost optimization and understand the principles. Next, always think about cost of technology and trade-off when you design your application architecture. After that, set up foundation for cost optimization in your AWS account and start implementing best practices. In the last stage, do more granular and deep analysis, reiterate and tune the best practice implementation. And most importantly, don't stop there. Optimize over time. Finally, to continue your journey of learning, we offer you various resources from AWS Training and Certification. Please visit aws.training to learn more. So, I really want to thank you for the time you spent with me today. I would love to hear your feedback, so please complete the survey at the end of this session. Have a great day.